2.6 Families of Functions. So we're going to be talking about different types of graphs depending on what the function looks like. First, these are all going to be parent functions. The parent function is what we base the initial graph off of. Now, I do not have tick marks on these graphs because I'm just going to be showing you what the shape looks like of the parent function. When I have y equals x, that's going to be a straight line. It's a linear function, and it would look something like this. This is the parent function. Y squared means there's a vertex, so a spot at the origin, and then it's a U shape at the origin. X cubed is kind of like a squiggle. From the origin on the right, it goes up. On the left, it goes down, kind of in a U shape. And finally, absolute value of x. Again, it starts at the origin, and it's a straight V. So these are all parent functions. Parent functions are always what we are going to be describing the transformation from. So these are the rules of any parent function of what the transformation would be. And here is I'm going to be using x squared as my parent function as an example. So first, vertical translations, either up or down. If I had something like x squared plus 3, that means the parent function moves up 3, so that vertex. If I had something like x squared minus 5, that means it moves down 5. The vertex moves down 5. Now, horizontal translation, you have to be careful because those can be very tricky. Those are always going to be inside the equation, meaning if I had something like x minus 2, this whole thing squared, this is going to give you 2 units to the right. Now, a lot of times when you see minus, you're going to be thinking left, but on the inside of the equation, so in between the parentheses, that's going to be the opposite. If I had something where it's adding inside the parentheses, like x plus 4 squared, that's going to move it 4 units to the left. Now, any number that's going to be multiplied on the outside of the equation, it's either going to be if it's larger than 1, so let's say if it said 5x squared, that's going to be a vertical stretch of 5 units. If it was 1/5, that's going to be a vertical compression. So anything less than 1 is a compression, and anything greater than 1 is going to be a stretch. And finally, if I have a negative, if that's going to be a reflection. If I have a negative outside of my function, so like x squared, that would be a reflection over the x-axis. So flipping it from up to down. If it's going to be something inside the parentheses that looks like this, that's going to be a reflection over the y-axis, so left and right. I would make sure to write down all these rules for reflections and different transformations. So first, if I give you an equation and ask what is the transformation, these are the questions you should be asking yourself. First, what is different from the parent function? What was added? And second, what does that do to the graph? If I look at this first problem right up here, what's different than the parent function? So this is going to be absolute value. This is not in my parent function, and this is also not in my parent function. So then I would look back at your notes. What do those two things do to your graph? Well, this negative on the outside of the function right here, that's going to give me a flip over the x-axis, or else you could also write reflection. And this 2 on the outside of the function would go up 2 units, or just up 2. So I want you to attempt this one next by yourself. So just the 3 is different than my parent function. So that's going to be only one transformation. It would be a vertical stretch of 3. Now if you look at this next one down here, there's actually 2 things going on here. You should pause the video and see if you get the 2 transformations correct. The 3 is on the inside of the equation, meaning it's being squared. Again, x squared is my parent function here. So that means it's going to be moving right 3, because on the inside it's always opposite that's shown. Since it shows a negative, that means it's actually be going positive to the right 3. And the 1/4 would be a vertical compression. And last but not least, pause to see if you get the last one. Correctamungo. Lastly, the 4 is on the inside of the equation because it's in between my my absolute value sign. That's going to move it left 4. Again, inside the equation is opposite that's shown. And then the minus sign's on the outside of the equation. Outside the equation is as is. So since it shows a negative, that means it moves down 9. You should make sure that you have these two written down in your notes right now, because that is your thinking process. And finally, if I give you the transformation, can you write the equation? So it's basing these two problems off the parent function of x squared. So it's telling me they have a right 4 up to and a vertical compression by 1/2. So I'm going to write my new equation. I'm just going to label it g of x because I don't want to label it f of x. I already have that as my parent function. The 1/2 has to be multiplied. So I'm going to put that out right in front. Either vertical compression or stretch always is multiplied. And right is on the inside of the equation. So I'm going to have x and 4, and then I have to think. On the inside, it's always opposite. So right is usually positive, so I have to have opposite of positive would be negative. That has to be squared because right is inside the equation. And up 2 is on the outside of the equation. So up would be plus, it would be plus 2, and that would be my equation for this transformation. Right now I want you to pause the video and try the last one by yourself. Last but not least, this negative right here would take care of my reflection over the x-axis. This plus 3 on the inside of the equation would move me left 3. Again, it's opposite on the inside of the equation. And down 3 give me a minus 3 on the outside of the equation. Make sure you took great, grand, wonderful notes. Hey, have a great night.